float type. Then /n is a return. So after this statement, a string will be a new string that is printed. Now we can use another function to print this a string into the msum output area. So msum has an output area, which we can print the string, print things. And that's the first part of this API manage function. Do you have any question about this?
But you didn't declare all the variables.
Which variables?
Oh, sorry, I already saw it.
Okay. So the variables are declared here.
Oh,
Here. Okay. Now this is the first part. Why do I say it's the first part? Because in msum we have two types of entities. The first type is called section. The second type is called a junction or a node. So we have already iterated through all the sections and we got all the vehicles information. But what about the vehicles that are existing in the junctions or currently turning, making turning movement? That's why we need another loop. So we use another function to find the number of junctions. And we have created a loop. And for each junction, we get its ID. And for each junction ID, we get the number of vehicles in that junction. Then we have created another loop. Then for each vehicle in the junction, we make a query by this function to get the vehicle information. Then we print another string, and we print it to the workspace or the output area. And finally, we have to return a 0, which means this function has been executed. Then this is the bracket for the whole function. So I explained a simple example to obtain all the vehicle information. And I think I believe you already understand, probably you have already understood how this works. All right? So do you have any question about this msum API? If I'm to review this, the most important thing is this figure. So you probably have to think about when will your code be executed. For example, if you want to control the vehicle at every simulation step, you probably want to change this post-manage function or the manage function. If you want to do something in the beginning of the simulation, you want to override this function. Similarly, if you want to do something after the simulation, you use this function.
So when you wrote your function, it replaced the manager function in this framework?
Currently, these functions are all blank.
All blank.
They are all blank. So it's expanding. You are expanding these functions.
But they are there. So each time asym runs, it would go and check to see if you have a function for the manager.
Yes, that's right. That's right. I think I may forgot one thing, which is how you can execute, how you can put your program into msum. And I think that's in the experiment part. So you can, for each experiment, you can specify in the manual that you want to load this DLL because this solution will be compiled as a DLL file, dynamic link library DLL file, which cannot be directly executed, but it contains all the functions that we need. So you compile this as a DLL, and you specify this when you run msum. I mean, in the msum experiment with the network. All right. Then msum will load your functions. So do you have any question about this? I want every one of you to understand. No? Okay. Good.
One question. So what kind of application can we do? Like, for example, in this msum?
What can we do?
Yes.
If we take a look at the msum menu here, we are going to see a lot of type of functions. So we have functions relative to manage control plans, functions relative to control junctions. We can relate it to ramp metering and traffic light. and management actions, detectors, and vehicle information. For example, we can control the speed of vehicles. We can output their status. So there are a lot of things related to the vehicle, which means you can control the vehicles according to your own logic. So I recommend you to scroll down to check this manual to see what you can do, because there are a lot of functions. All right. So any other question? That was a very good one. Okay. So the second thing is parametrics. The idea of parametrics API is very similar to MSUM API. You still have to create your own functions to override some functions. But let's go step by step. In the beginning, we have to know two folders. In parametrics, the important things are stored in two different folders. The first folder is called, I would call it a program folder, which is under the program files. The second folder is a data folder, which is in Windows 7, it will be stored under users public parametrics. So a lot of information, a lot of important files are stored in the data folder. That's the first thing. Now, the sample projects are located at data folder /programmer/plugins. You will see a lot of sample projects there. Now, if you go into this folder and open base/base.solution, and currently it doesn't support Visual Studio 2010. You can only use 2005 or 2008 to open it. Then you will open this project. This is very different from the one we saw in MSUM because it has only one file called plugin.c. That's the minimum. And you don't see these header files, correct? There's no header file, so it's different. But these header files are also specified in the solution file. I'm going to show you. But you open this solution, you see only one file. Then you modify this file. All right? Then there is a compiled HTML file, help file under data folder. Open this whenever you need. So I have already opened it. This is the compiled, the aggregate manual of parametrics. Under contents, parametrics product suite, programmer, you will see something like introduction, like function explanation, these things. Okay, so we kept that open. Then we go on. We already saw that that's plugin.c file. Doesn't come with those additional header files, but the header files are very necessary. So we have to specify the location of these header files in the project setting. So we opened it using Visual Studio. First, we have to do four things. The first thing is the output, which is a dir file. Dir file has to be stored under the program folder of parameters. Then we have to set these things. This is the additional library directories, which are some pre-compiled libraries, binary libraries that we have to call. So this is one thing we want to include, we want to specify. And we have some header files, which is specified to be under their folder /programmer/include. I will show you how to do that, but these are things we'll have to do. And for these libraries, basically we want to add the dependency on this modeler.library and simcall.library. So basically we have to set up these four things. So this is the first picture. So if you open the setting of the project, under linker general, you will see these two things. They have to be modified according to my previous slide. Then this one, C++, C++ general. This is the additional include directories. And this is the linker tab. It's going to add these dependencies. So 4 locations to set up. Remember this. in this file, in this solution, they probably have already been set up. But if you want to create your own program, you have to do these 4 things. Now, after setting this, after writing your program, you want to compile a program. So the program can be compiled into a DLL file. For example, let's name it as plugin.dll. Then you need to add this file name into a text file called programming in the parametrics model folder. It's a text file. Then you can load the parametrics model and run, and your plugin will be executed. So this is an example. So in this example programming file, I use pound to comment these 2 DLLs, so they will not be loaded. But line 2 and line 4, these 2 DLLs are going to be loaded. Parametrics allows you to load multiple DLLs. All right. Now let's go into the program details. So the first thing is in parametrics, they use a lot of abbreviations, three-letter abbreviations. For example, they use NDE to stand for node. They use VHC to indicate vehicle. I just want to mention there is a table, so you can check which means which. Because in their function name, they use this quite often. Now, okay, in parametrics, there are four types of functions. The first type of function is called QPG, which is used to get a value from an object. So an object may be the vehicle. We want to get the vehicle speed, so we'll probably get QPG slash QPG underscore VHC underscore speed, which means we can use this function to get the speed from the vehicle. Similarly, we have QPS, by using which we can set a value. For example, we can use QPS to set the speed. We can use QPX function. Okay, these are 2 functions that become a pair. So we have QPG to get a value, we have QPS to set a value. There are 2 kinds of functions which are equal to the msum functions. I like the msum functions that will be called by the system. So QPX is a function that will be triggered by some events. So these are not functions that we use. These are functions that parametrics will call. So parametrics will call these QPX functions. And parametrics will also call some QPO functions. QPX function is now completely empty, so we can add as many things to it as possible. They will not affect the current behavior. But QPO functions are functions to override the current behavior. So parametrics already has some implementation of these functions. So if you write your QPO function, they are going to override the current behavior. So do you understand all the meanings of these 4 types? Please ask a question if you don't understand.